Hello Year 12 and welcome to your second dot point in maintaining a balance. It is 9.2.1.2. Identify the pH as a way of describing the acidity of a substance. So first things first, we need to unpack the dot point. This is quite a simple dot point. It's not asking you to be able to do this in a lot of detail. All you need to be able to do is identify the pH as a way of describing the acidity of a substance. So identify just means recognise a name. In this particular case, the word describing is not what they're asking you to do. It's more in terms of the definition of what pH is. So, what is pH? As we've said, it's the way of describing the acidity of a substance. So, acidity is caused by the presence of hydrogen ions in a solution. Hydrogen ions are literally the hydrogen that you see on the periodic table, that particular element. That is what causes pH. And the pH scale is used to measure how acidic or alkaline, and alkaline also means basic, a substance is. So the pH scale ranges from 0 to 14. A pH of 7 is neutral. A pH between 8 and 14 is alkaline or basic. And a pH from 0 to 6 is acidic. And the further we get away from the number 7, the more strongly acidic or basic something is. So something with a pH of 1 is much more strongly acidic than something with a pH of 5. And here you can just see some examples of everyday substances and their pHs. So you can see, because we're doing biology, look at some of the biology related things. Hydrochloric acid is what's found in our stomach. It's very strongly acidic. It has a pH of 1. We can also have a look at healthy hair, skin and nails. It has a pH of around 5.5. Again, acidic, not nearly as strongly as hydrochloric acid though. Urine, saliva and milk all have the same pH of 6. Our blood has the same pH as pure water. Our blood is neutral. And there's lots of other substances on there, but I won't go into too many more of them. So pH is actually a logarithmic value of the concentration of hydrogen ions. So what that actually means is that a change on the pH scale by just one number actually shows that the hydrogen ion activity changes by a factor of 10. Okay, so if we have a look on this chart, we can see that at number 6, the concentration of hydrogen ions compared to water is 10, whereas at 5, the concentration of hydrogen ions compared to water is 100. So it's 10 times greater, even though there's only a change in the number 1 between the two. And just a little bit of extra information. You don't necessarily need to know this, but because we're doing biology, we're focusing on homeostasis and things like that, I just wanted to give you a bit of context on why we actually care what pH is and that kind of thing. So pH is very important in our bodies. Obviously, as you saw, different areas of our body have different pHs, and different things work in our body at particular pHs. And if we change the pH, things can stop working. So for example, different enzymes in our body, and you guys hopefully from the last lesson have a fair idea of enzymes and why they're important now. So different enzymes in our body have different optimum pHs for activity. And they can only tolerate a reasonably small change in the pH. If we change the pH too much, it reduces the enzyme's activity, so it basically stops working. Because a change in too much pH causes the enzymes to denature, is what we call it, which basically means they distort and their shape changes and they lose their activity and can't work anymore. So you can see the example in this graph. If we look at pepsin, it's a digestive enzyme found in the stomach. We know that our stomach has a very acidic environment. So it has an optimum pH of around 2, but it'll work fairly well between a pH of 1 and 3, which fits because we know hydrochloric acid has a pH of around 2. If we have a look at trypsin, which is a different type of enzyme, it's a digestive enzyme as well, but it's found in our small intestine. And our small intestine has much more of a basic pH, so it has a pH of around 7.4 depending on where you are in it, and we can see that trypsin works the best under these conditions. If we change the pH and the pH becomes too acidic, trypsin stops working, so the enzymes in our body stop working. So that's a bit of a background, but main important thing to know is that pH is a way of describing the acidity of a substance.